These are my vectors. It's an n-tuple case. It's the second one. Third one, and I know what happened to it. Actually, in this example, we have the same three vectors, but I would like to address the question in sort of in parametric version or conditional version of that question. You see, my B vector this time is not a numerical vector, but the one with the parametric values. And again, I raise the same question whether my B belongs to the span. That's a question mark. We need to answer this question. We start with definition again. We spell out the linear combination of my x vectors, introduce these unknown coefficients, and raise a question whether we can find B like this. Whether we can find coefficients like this. Lambda B, we don't have to look for B. This is a system of linear equations. These are the coefficients. Again, if you struggle with this, linear dependence examples, they had more details. There were same vectors there, but more details. And the step two, there was this one extra intermediate step in between this and this, where we just filled in the x vectors and spotted system of linear equations. This is already the augmented matrix of that system, which we now take to row echelon form. That's the row echelon form. This reminds a lot, if you've been following, this reminds a lot, remember those examples in systems of linear equations with conditional right-hand side? It's very similar to that. And now we have to ask the question whether it's solvable and what are the conditions on the B1 and B2 which ensure solvability. If you follow those examples, if you checked all of those, there were quite a few, you know the answer. We don't have to have any conditions on B to ensure summability because all pivots on the left-hand side, no matter what B1 and B2 is. So from this perspective, we now conclude that this will always be true, no matter what the content of your B vector is. No conditions needed on this to ensure this statement. And that's exactly the example of spanning, right? Because any vector in R2 is of this type, and it looks like it will always be in the span. Span coincides with the entire vector space. So this example actually helps me to establish that this set is spanning. Spanning set. Another point which I'd like to make here is actually when you test for spanning, the right-hand side is not really relevant. I could have just left blanks here and still see the same conclusion because all I need to spot is the pivots on the left-hand side. It's the left-hand side which governs your decision. So if you do it in a time-stressed environment and you're testing for spanning, you can actually neglect this right-hand side. All you care about is the left-hand side. Oh, wrong one. Not for you. All you care about is the left-hand side. And that's what I would normally do if I do it in a time-stressed environment, because all I need to know is where my pivots are, whether all of the pivots on the left-hand side. And for that, you don't need to have the right-hand side. And that's why they said it's spanning. Any questions?